Hey guys, hello everyone and welcome to another video of Aptitude for CSIR NET series. Today in this video we are going to talk about area related questions. Now in CSIR NET, if you will see the previous years of CSIR NET exam, you will find out that there are many questions asked based upon areas, areas of figures. And they generally ask to find out ratios of areas of figure, but for that you should be aware about different formula used for calculating areas of different figures, right? Now many students, either they don't remember the formula or they don't know how to apply it, so that is going to be the sole motive of this particular video, where I am going to discuss about some general figures, some general shapes and the formulas related to them, and once we will be done with it, we will try to solve some previous year's question. Also at the end of this video, I'll be giving you a homework question so that you can practice of your own, and I'll be solving the previous videos homework question in this video as well. So stay tuned for that. Also, if you are new to this channel and you have not subscribed it yet, please do consider subscribing it. That gives me a lot of courage to make more videos for you guys. Alright, so having said that, let's continue with our video now. Alright, so these are some general figures, some general shapes for which formula you should know. So the first one is a square. So if for a square, if the side of a square is given as a unit long, okay, so all the sides of a square are same, so the area of a square is equals to a side square, okay, that means a square. Then if this is a rectangle, okay, so if you are given with a rectangle whose length is, let's say, a unit and its width is, let's say, b unit, in that case its area will be given as a into b. All right, now this is a circle has a radius of its own, so the area of circle is given as pi r square. Now if let's say this circle is half, that is semicircle, in that case that will be pi r square upon 2. Okay, so I'm writing here itself for semicircle means a circle like half of the circle. For that, area will be pi r square upon 2. Now this is a triangle. Let's say the length of this side, this is the base, let's say, and this is the height of the triangle. Okay, from here to here is the height of the triangle. Height means it is making 90 degree with it, right? So that makes the height. And if let's say this side is base, which is given as b, let's say, so the area is given as half base into height. Okay, this is the formula to calculate area of a triangle. Now if the triangle is equilateral triangle, that means if all the sides are same for the triangle, that is a units, in that case the area of a equilateral triangle is given by root 3 upon 4 side square. Alright, now this is a trapezium. Okay, this is a trapezium, and for trapezium the property is that it will have two parallel sides. So let's say if this parallel side is given by b units and this parallel side is given by a units, and you know the distance between them, means you know the height of them, in that case area of trapezium will be given as half sum of parallel sides, that means a plus b into height. Okay, so this is a parallelogram. Okay, this is a parallelogram. The area of parallelogram is given as, like, the difference between trapezium and parallelogram is it has two parallel sides and those, like, set of two parallel sides, and the parallel sides are equal in length. So if this is b units, the above one will also be of b units. Okay, same length. And if this side is of a unit, this also will be of a unit. Alright, and if let's say the height of this parallelogram is given as h, in that case area will be given as b into h, base into height. Remember on which base the height is being made, that base we will use, so b into h. If this perpendicular would have been drawn like this, and if its unit was, if it was, let's say, l unit long, okay, so area will be given as a into l. Why? Because now this perpendicular is on a base. Okay, so in a parallelogram there are two possibilities, two heights possible, and based upon any of the height on which base that height is constructed, based upon that we write down the area of it. Alright, so these are some important formula, some important shapes for which you should know. Now there are some like some advanced structures or some additional structures for which you should know. For example, area of segment. Okay, now basically if there is a circle and if you just cut out a segment of a certain angle, okay, by some angle, and you want to find out the area of this segment which makes angle theta, so for that area is given as theta upon 360 pi r square. Okay, this is the formula, and if r is the radius of it. Alright, similarly if you have a triangle whose height you don't know but you know the sides of it. Okay, so if there is a triangle of three sides, let's say the sides of the triangle are, and the triangle is not equilateral either, right? So you have a triangle whose one side is a unit, the other side is b unit, and the other side is c unit long, and you don't know the height and the other property of it, and you want to find out the area of it. So area will be given as under root s minus a, s minus b, s minus c. What is s here? So where s is semi-parameter, or a plus b plus c upon 2, means sum of all the sides divided by 2 will give you s, and once you find s you can find out area by using Heron's formula. Okay, this formula is called as Heron's formula. So these are some basic things which you need to know in order to find out area of some specific figures. Now I will take some questions because that is more important to understand, and it's more important to know how to use this formula to find out or to solve a question. So let's take some question from previous years. Alright, let's take this question which was asked in CSIR June 2021 exam. Okay, now the question says that DRQP, this is small square, is a small square of side small s in the corner of a big square ABCD. So ABCD is a big square, this is a small square, the side of big square is capital S. What is the ratio of area of quadrilateral PBRQ? So PBRQ, okay, so they are talking about, okay, let me highlight this, they are basically talking about this quadrilateral, okay, made by these four lines. Now there is no direct formula to calculate area of quadrilateral. Okay, so they are asking what is the area of this quadrilateral to that of the square ABCD, given that capital S upon small s is 3 units. Okay, now as I said, there is no direct formula to calculate area of such quadrilateral which is not a proper shape. So for that we will use the help, or we will take the help of areas of smaller shapes which we know to find this out. Okay, so how you can find out, or how you can fetch out this shaded region from this whole region? Okay, how you will do that? For that you have to subtract, or I should write down area. I am writing AR means area of PBRQ, which is this shaded region. This will be equal to area of ABCD. That means if from this whole square, if I subtract, what I should subtract? I should subtract area of DRQP. That means this is smaller square I have to subtract, and I also have to subtract this triangle and this triangle. So I have to subtract area of triangle PAB, and also I have to subtract area of triangle RCB. Okay, so this much if I do, I will be able to get the required area. Now to get that, I should first of all write down the sides and all. So over here the side is capital S, this side also the side is capital S, as they belong to the capital or the bigger square. This side, the side is small s. Okay, small s. The side AP will be capital S minus small s, right? This from here to here. And similarly this side RC will be, this is capital S, this much is small s, so this will be capital S minus small s. Okay, so I got the things now. Fine. So area of ABCD is pretty simple, since the side of the square is capital S, so it will be capital S square minus area of DRQP. DRQP is a smaller square of side small s, so small s square, minus area of PAB. This is the triangle. Now triangle is making 90 degree, so you will be using this formula, half base is AB, that is capital S, and into height is capital S minus small s. Same goes over here when I calculate the area of this triangle RCB. So again this is 90 degree, so this will be half, again the base is capital S and the height is capital S minus small s. Alright, so this whole thing will give you the formula. Now will give you the answer. Now since this value and this value are same values and they are minus minus, so they will be added. Half and half of anything added 2 times becomes 1. So this will be capital S square minus small s square, and this whole will become minus capital S minus small s. Now I can open the bracket to solve it further. So this will be capital S square minus small s square minus, when I multiply here, capital S square plus capital S small s. This minus and this minus became plus. This and this will get cancelled out, and I will get capital S small s minus small s square as the area of PBRQ. Now my thing is done. I only have to find out the ratio. So required ratio will be area of PBRQ divided by area of ABCD. So when I calculate PBRQ, that is capital S small s minus small s square divided by capital S square. What I can do is I can separately or take these like do these two things separately. Okay, so what I will get from here, or simply what I can do is divide numerator and denominator by small s square. Okay, so what I will get if I divide the numerator by small s square, it will become capital S small s upon small s square minus small s square upon small s square divided by capital S square upon small s square. The reason of doing that all thing is to get in the term of capital S upon small s. Now here your one of the small s will cancel out one of the small s. Here they will cancel out, become 1. So here you will get capital S upon small s minus 1 divided by capital S upon small s ka whole square. Now the values you have to substitute, its value is 3. So if you put 3 here, so this will be 3 minus 1 divided by 3 square. So that will make it 2 upon 9 or 2 ratio 9, which is option number A, and that's how it needs to be done. So it was pretty simple. It looks little bit difficult. That's because the structure was, or the area which was asked is not a standard shape, but you can get that by subtracting or adding different shapes and getting the answer. I hope this is clear to you. Now I will take the next question. Alright, so this again is a nice question asked in CSIR June 2019 exam. It says 3 semicircles are drawn inside a big circle. You can see them as shown in the figure. If the radius of the two identical smaller semicircle, means they are talking about these, okay, so if the radius of these smaller semicircle is 1/4 of that of big circle, okay, so let's assume that the big circle has a radius of let's say the radius is capital R. Okay, now it says that the radius of the two smaller semicircle, means these two, the radius is 1/4. So the radius of this will be capital R upon 4, right, for both of them. 1/4 means capital R. If it is capital R, 1/4 of this will be R upon 4. Then it says the radius of the bigger semicircle, which is this one, is twice that of a small semicircle. Means this is going to be capital R upon 4, which was this, and twice of that. So this will be nothing but capital R upon 2, right? So I'm just writing it over here for the sake that you understand. So radius of bigger circle, the circle which is the biggest one, the radius is capital R. Radius of smallest semicircle right? These two I'm talking about. So their radius is capital R upon 4 according to the question I'm taking, and then radius of smaller semicircle, means semicircle is smaller, that means I'm talking about this one. This will be R upon 2. Okay, so what portion of the big circle is shaded? What part is shaded? You have to tell. The portion means ratio is what you have to tell. So first of all we have to find out area of shaded region. For that, what I will do, area of big circle. Okay, from here I will subtract 2 times of area of smallest semicircle, right? I'll subtract these two semicircle, and then I will subtract once area of smaller semicircle, means this one. Alright, so area of bigger circle is pi r square, as I told you. Capital R is what we will take, minus 2 times of area of smallest semicircle, means the area of semicircle is 1 upon 2 pi r square, right? So r of this is capital R upon 4, and minus smaller semicircle, again it is semicircle, so no 2, so it is 1 by 2 pi r by 2 square. Remember, I'll write down here that area of semicircle is given by 1 by 2 pi r square. You should know that r is the radius, so I'm just directly putting the radius values here. Okay, so this will be pi capital R square minus, if you solve this you will get pi r square upon 16, and if you solve this minus, this will be 4 2 times is 8, so this will be pi r square upon 8. If you solve this, the denominator will be 16, so this will be 16 pi r square minus pi r square, and yeah, minus 2 pi r square, right? So if you solve this whole thing, you will end up getting 16 minus 3 is 13 pi r square upon 16. So they are asking what portion of the bigger circle is shaded. So ratio which you need to find out, required ratio, will be 13 pi capital R square upon 16 divided by area of bigger circle, that is pi capital R square. So this and this get cancelled out. Answer will be 13 upon 16 or 13 ratio 16, which is option number 3. So this is how it needs to be done. The only thing is we are just using basic formula of areas. The only thing is you need to understand that how to apply them, okay, when you have various different shapes in a same figure. Alright, again this question was asked in CSIR December 2019 exam. It says in the diagram, what is the ratio of total shaded area of the circle and semicircle which is given to you to the total area of square and rectangle. Okay, very simple it is, but just the way how they have asked is different. Okay, so what they have given, A is the length of the side of this square. So if I call this as a circle, so the radius of the circle will be how much? It will be a by 2, right? Half of a. Same goes for semicircle also. From here to here it will be a by 2, and this whole length will be a, right? So considering all this, what I will do, area of shaded region, this will be equal to area of circle plus area of semicircle, right? So area of circle is pi r square, in the place of radius it is a by 2 square, plus area of semicircle is 1 by 2 pi r square, so radius is again a by 2. Okay, so if I solve this, I am going to get pi a square upon 4 and plus pi a square upon 8. Okay, LCM will be 8, and it will be 2 pi a square plus pi a square, which will give us 3 pi. So this will be 3 pi a square by 8. Okay, this is what we will get. Now required, okay, this also we have to find out total area of square and rectangle, which is the other part which we have to do. So total area, okay, that will be given as area of rectangle. This is the rectangle, okay, but first of all let's talk about square. So area of a square is a square plus area of rectangle is length into width. Length is a and width is a by 2, right? This is a by 2 and this is a. So this will become a square plus a square by 2. If you solve this, you will get 3a square by 3a square by 2. Now you need to find out required ratio. So area of shaded region, you have to put area of shaded region divided by total area. So area of shaded region is 3 pi a square by 8 divided by 3a square by 2. So a square and a square will get cancelled out, 3 and 3 will get cancelled out, 2 will cancel out 4 times. So basically we will get pi by 4 as the answer, which is option number 4th. So this is how it needs to be done. These type of questions are very simple and very straightforward. All it needs is to analyze the question properly and to look upon the figure and then try to do it. Now I'll give you a homework question so that you can practice of your own. And now today I'm going to give you a homework question from previous CSIR NET exam itself. Okay, this was asked earlier in CSIR NET exam. The question says that ABCD is a rectangle. Okay, remember ABCD is a rectangle and O is the midpoint of AD. This O is midpoint of AD. Okay, P and Q are points on AB and CD. So P is some point on AB, Q is some point on CD respectively, such that AP is equals to 1 by 4 of AB. So this length from here to here, the length AP is equals to 1 by 4 times of this AB. So if this AB is of length x, this length will be x upon 4. Same goes for DQ. So DQ is 1 by 4 of DC. This total length, this part is 1 by 4 of that. What they are asking is ratio of area of rectangle ABCD to that of the triangle OPQ. So they are asking the area of this triangle OPQ and the complete rectangle. Ratio of these two areas is what will be the final answer. Think about it, try to do it on your own and do let me know the answer in the comment section. Okay, and in the next video I'll explain you how to solve this question. Now is the time when I'll be solving question which I gave in the previous video for you guys as a homework question. Alright, so this was the question in my previous video where we have discussed speed and time. So there I have given you a question that a man completes a journey in 10 hours. He travels the first half of the journey at the rate of 21 km per hour and the second half of the journey at the rate of 24 km per hour. Find the total journey in kilometers. Okay, so many of you have answered it correctly, but let's look how to solve it. So let's say that a person has to go from some point A to some point B. Okay, let's say that the total distance from point A to point B is small d. Okay, this is the distance. Now the person travels the half of journey. Let's say this is the half point. Let's call this half point as point H. Okay, I'm just calling it as point H. So the distance for this much will be how much? D by 2. So he is traveling D by 2 distance with some speed which is 21 km per hour. In the second half, which is again D by 2, he is traveling this as 24 km per hour. So let me write down all the scenarios here. So I'll write down speed, I'll write down distance, I'll write down time. Okay. Now speed is 21 km per hour. Distance which he traveled is D by 2. Here then the speed is 24 km per hour. Distance is again D by 2, right? Both the distances are same because it's a half point. So we know that time is equals to distance upon speed, right? We know this. Using this we will find out time used in this case. So time will be distance, that is d by 2, upon speed, that is 21. And here since the time distance is d by 2, speed is 24. So this will become basically d by 2 into 21, and this will become d by 2 into 24, or you will call it d by 42, and this will be d by 48. Okay, so we have got the two times which we have, and these add some like if this is time t1 and if this is time t2, which is time required to complete both the half, total time is 10 hours. So you can simply equate with it. So we know that t1 plus t2 is equals to 10 hours. Using that, I will put the values 42 plus d by 48, this is equals to 10. Now all you have to do is you have to solve taking the LCM and doing it. Okay, so we can take the LCM simply as 48 into 42. This will become 48d plus 42d. This will be equal to 10. So if I sum the numerators, it will be 50 plus 2, 4, it will be 90d, and this will be equal to 10 into 48 into 42. So the value of d will be 10 into 48 into 42 divided by 90. This 0 and this 0 will cancel out 3 times, 3, 1 and 6 times, then 3, 1 and 4 times. All you have to do is multiply 16 with 14, and that will give you 224. So your final answer should be 224 kilometers, which many of you have done it correctly. Very nicely done, and that shows that you guys are understanding the concept and you guys are getting what we are discussing in the videos, right? So yeah, that's all for this video, for this particular video. That's all from my side. So thank you so much for watching, and if you guys want, you can follow me on different social media platforms. These are the different links for that. Links are also in the description of this video. You can directly follow me on all the social media platforms using those links as well. So that's it from my side. See you guys in the next one. Till then, have a great day. Bye bye, take care.
Hey guys, so Unacademy has launched a Revise India series. It is a free video series for CSIR NET June 2023 exam. In this series, you will be able to attend free sessions by the India's top educators for CSIR NET. These sessions will be very helpful for your CSIR NET preparation and for your June 2023 exam. So all you have to do is follow the link given in the description of this video. You will come up to this particular page. There are various educators whose classes you will be able to see. All these classes are free of cost, so you can watch these classes. You will be able to see the classes of all the subjects over here. So depending upon which subject you belong to, you can choose a particular class, a particular educator, a particular topic, and watch that particular class.